Good afternoon, everyone, and welcome to the fifth session from Grapes to Wines Cold Climate Webinars. My name is Francisco Diez. I am the Viticulture Specialist at Perennia. And at this opportunity, my co-host will be Neslihan Ivit, the Winemaking and Innovation Specialist at Perennia. In this session, we'll be talking about wine grape cold cases, frosts, freezes, bad hardiness, and viability. Everything will be presented by Dr. Harrison Wright from Agri-Food and Agriculture Canada. Before moving forward, I would like to give some Zoom housekeeping. All participants will have their audio and video turned off during the webinar. If you would like to ask a question, please use the Q&A feature at the bottom of your screen. The chat and the Q&A will be monitored throughout the session by Nestle, and all the questions will be addressed at the end in the Q&A session. Let's give a brief introduction of Perennia. Our vision: Nova Scotia is a recognized world leader in producing innovative, environmentally responsible, safe food of impeccable quality. Our mission is supporting growth, transformation, and economic development in Nova Scotia's agriculture, seafood, and food and beverage sectors. Our services covers different areas such as agriculture, quality and food safety, product development, lab services, and fisheries. More precise to the wine industry, we are working from vine to wine. So we are providing services since the inception of the project. For example, site assessments, viticulture management practices, plant health lab, which is not only virus disease, also other diseases, winemaking services, mobile bottling and filtration unit, and development services. Before starting the topic, and at this opportunity, we have people coming from different areas, we would like to give a brief introduction of viticulture in Nova Scotia. The wine growing region here is a cool climate, and all the conditions shows that. In growing degree days, we have around 1,100, while in frost-free days, we have around 160 days. According to different indexes, we can corroborate this. Winkler shows that Nova Scotia is a cold area, while Hagelin shows it's a very cool climate. While in cool night index shows the area, it's a very cool area. Nova Scotia, we have different varieties, which are a combination between hybrids and Vitis vinifera. Currently, hybrids represents approximately 75% of the whole surface. The most planted variety in the province is L'Acadie Blanc, which is a hybrid. But also we have New York Muscat, Seyval, Vidal Blanc, Leon Milot, Maréchal Foch, and etc. Meanwhile, in the Vitis vinifera, they have been becoming more and more popular in the last 20 years. The second most planted variety in the province is Chardonnay, a Vitis vinifera variety. But also we have others such as Riesling, Pinot Noir, Gamay, Meunier, Sauvignon Blanc, etc. All these varieties have different tolerance to low temperatures. For example, L'Acadie Blanc has a low temperature exotherm, which is LTE 50, of minus 28.9 degrees Celsius. Meanwhile, Chardonnay has an LTE 50 of minus 25.3 degrees Celsius. What means the 50? It means that at this temperature, the 50% of the vats lose their viability. I would like to highlight that Agriculture, Agri-Food Canada, the last couple of years, has done every winter a bad hardiness survey. All this information is available in different reports through the GGANs distributed to the growers, but also appears in the CGCN website and also in the Grape blog. So I would like to encourage you to check one of these websites, and soon you will see the link information in the chat. So let's go to introduce our speaker today, which is Dr. Harrison Wright. He is the lead plant physiology and Kentville Research Development Center, KRDC. Dr. Wright has a PhD in biology, plant physiology, and a Master of Science in Agriculture. He leads the plant physiology program at Kentville. And here he has conducted several trials and surveys examining cold weather and grapevine performance. Dr. Wright will discuss lessons learned from the bud Hardiness Survey, post-spring, post-winter, and freeze pruning strategies, harvest timing, and hardiness.
All right. Well, first of all, thank you, Francisco, for the kind introduction. I want to thank both yourself and Nestle and Perennia for giving me this opportunity to speak to all of you and to give a platform to do that. As Francisco says, my name is Harrison Wright. I'm the plant physiologist at the Kentville Research Station here, part of Agriculture and Agri-Food Canada. And today I'm going to talk to you about wine grape cold cases. So essentially, we live in a very cool climate for wine grapes, although several of them do thrive here. And the last several years, we've been focusing on various things to do with the cold weather and growing wine grapes in our climate. So very quick overview of what I'll be talking to you in the next 30 minutes or so. First of all is bud hardiness. So very important to know the hardiness of your vines before you plant them. And even and the bud hardiness can change from region to region or from cultivar to cultivar. In certain regions, the same vine like a Lacadie or a Chardonnay will grow more tolerant than another one. It depends on the length of the season, depends on how you ease into winter and things of that nature. So first I'll talk a little bit about our bud hardiness survey and some of the things we've learned conducting the bud hardiness survey. Secondly, is last year, we started also doing something we call a bud viability survey. So bud viability and bud hardiness are two different things. Hardiness, of course, is the cold temperatures that your buds can tolerate. Bud viability is essentially whether your buds are alive or dead. Sometimes they die because of cold temperatures. Sometimes they die before that for reasons that we're investigating, such as being dehydrated or not being very strong in the first place because you had a weak growing season or things of that nature. So it's important to understand how viable our buds are. Thirdly, I'm going to talk about two trials we've conducted in the last few years, and they're both post-frost freeze pruning trials. We've had, unfortunately, a fair bit of opportunity to study this in the last few years alone. And finally, I guess I was going to mention what the trials were. So people from Nova Scotia anyway will of course remember not so fondly the 2018 June frost. We did a post-freeze pruning trial after that. And this past year, not everyone might be aware, but certain places are definitely aware, is we had a very cold temperature in February of last year, February 15th. So we also did a post-freeze pruning trial of that. That's still in progress, but we'll report the preliminary findings there. And finally, we'll talk a little bit about this. I know there's already talk here from France about frost protection. I'll talk about that a little bit, and also about temperature inversions, whether we have them, what the percentage of cold or frost are actually from temperature inversions here in Nova Scotia. And also, we recently acquired a frost fan at the research station, so I'm going to talk a little bit about frost fans and what they can be used for and what we'll be doing and how we'll be using ours at the research station, or what it looks like and how we use it. So I guess getting right into it, bud hardiness. Our bud hardiness survey, we measure a lot of vines throughout the season, usually, but there's 5 core ones that we follow particularly. And that's, we wanted a white hybrid and a red hybrid. So Lacadie Blanc, as Francisco said, is our most common white hybrid grown here in Nova Scotia, predominantly grown just in Nova Scotia, although it is located a few places elsewhere. Marquette is a nice red hybrid in my opinion, so we follow that one. It's known for being particularly hardy, developed in Minnesota. And then some of the 3 most popular vinifera that we also grow here in Nova Scotia, which is Chardonnay, Pinot Noir, and Riesling. When we do the survey, we follow these cultivars in 23 different varietal blocks. So we visit these 23 blocks every 2 weeks like I said, we take samples bi-weekly. And for the most part, we usually in a typical year, we start the bud hardiness survey after harvest, mid-fall, around late October / early November, and then we carry through with the survey usually until the end of April or like the first week of May. Essentially, we just follow the dormant season when the plants go into dormancy, and then when they come out of dormancy. So a little bit about what we do. Some of you are familiar with this. Some of you probably heard me say this before, and some of you, this might be new to you, but essentially, we collect canes from these 23 varietal blocks. We bring them back to our lab at the Kentville Research Station. The sites are all around Nova Scotia. We go to the South Shore. We go down to, close to Digby, most of the valley. And we bring those canes back to the lab, five canes per site. And we take a particular nodes, the ones that are predominantly in charge of, or predominantly have the fruitful buds in them. We take those buds off, we cut them off, and we place them on a cell that contains a pelt-shaped plate. And a pelt-shaped plate is a specific device that it translates differences in temperature across it into a voltage signal. So that's where we get our signal from. These trays are loaded into a programmable freezer that simulates a deep freeze event. So it's programmed, it begins at around, I think it's 4 degrees Celsius, and it goes down in stepwise fashion over several hours, pretty well mimicking what you might get from a temperature inversion. It goes down, and over, I don't know, I can't remember how many hours, but over the evening, it steps down to very cold temperatures, down to into the -30s, up to almost -40. Or down to almost -40. And this is what's produced afterwards. And this is where we get our data from. So these pelt-shaped plates, like I said, they take a temperature inversion over them and convert it into a voltage signal. And it creates what's called a thermogram. So on the x-axis here, you can see our temperatures. This is when we first load the trays, and we launch a program late in the afternoon, and then it runs overnight, going down through these temperatures. Then we start getting these signals. And these are what Francisco explained are low temperature exotherms. It's exotherms because the water in the bud freezes. And when you have water going from a liquid state into a solid state, you're going from a higher energy state into a lower energy state. And because of that change, the difference is released as heat. And so you get a little bit of heat given off by the bud or by the water when it goes from a liquid to a solid. And that heat raises the temperature on one side of the pelt-shaped plate, which makes a temperature differential. That's why we call it differential temperature analysis. And it creates an exotherm, which turns into a voltage signal. So each one of these bumps here, you can see that is one of these buds going off. This little one was probably like a secondary bud, and this big one was probably a primary bud. And you look at what temperature those happen, and that can tell you how hardy those buds actually were. So here is the averages for the peak dormancy part of the year, which is approximately we reach peak dormancy, late in January, usually mid to late January. So and it continues into February through to March before they start losing their hardiness. So we thought it'd be interesting to just look at the averages over the last few years. This is the last 3 years of how hardy they were. You can see Marquette is very hardy, like I said, developed in Minnesota. Whenever I think of hardy grape, I think of Marquette for our local area. It's one of the hardiest ones we have. It usually gets up to -30 at its peak hardiness. You can see Lacadie is a little less than that. It's hardy. It's a hybrid. Most hybrids are hardy, but it's not a particularly hardy hybrid. So it's usually around 26, 28 degrees. That doesn't sound like a big difference, 2 degrees, but that actually is pretty big in the grape hardiness world. And then you can see the vinifera, Chardonnay, Pinot Noir, and Riesling are all down there around 23, 24, sometimes as high as 20 or as low as 25. I would like to note that it changes, what's hardy in a given year and what's not hardy can change from year to year. And this is kind of interesting, and this is anecdotal, but for instance, this past year in 2020, we had a very long, warm season. It was quite good growing season, even though the crop was down for other reasons. But you can see Marquette is one of our shortest. It's not only the hardiness and not coincidentally, it's also one of the shortest season cultivars. It's meant to grow in a place that has a very short summer. So it's kind of interesting that on this very long season, it actually has one of the lowest hardiness levels that we've had in the last 3 years. And that could be because of it's a short season grape growing in a long season, or it could be because it's also deacclimates quicker than most other grapes. Again, it's used to growing in a very cold place with very short seasons, so it jumps at the chance of any heat. It deacclimates quickly. On the other hand, Riesling, I would say, is probably our longest season grape that we grow here in Nova Scotia. It requires a long season to really get full maturity. It's interesting to see that in light of this long season we had in 2020, it's actually at the hardiest it's been in the last 3 years. You can see it's almost minus 26, which is very hardy for a Riesling. And it's harder. That's the hardiest it's ever been for us. And if you went back to 2018, that was the year of the June frost, where we had almost the shortest season on record. You can see Marquette had no problem with that. It reached minus 30. It's a short season grape. It was growing in a short season, and it reached a respectable hardiness level. But Riesling, on the other hand, again, one of our longest season grapes, that was the least hardy it had ever been in that short season. It started late, got frost a little bit, and then the season shut down early. A lot of places got frosted in middle third week of September. It didn't like that, and consequently, it was not very hardy that year. It was only minus 23. So you can see 2018, the year of the frost, very short season, compared to 2020, one of our longer seasons. We have a difference of over 2.5 degrees, which might seem like a small thing, but that's actually a pretty significant difference in terms of bud hardiness. So again, to rank our cultivars, this is just to rank the 5 key cultivars that we follow as part of the Bud Hardiness Survey. Marquette, consistently every year, even in 2020, when it wasn't as hardy, it's always #1 in terms of hardiness. Lac-a-Dee, or other hybrid, is consistently #2. And the Chardonnay, Pinot Noir, and Riesling, the vinifera, they like a little bit warmer region, but we can grow them here. You can see it's all over the map. One is not really particularly hardier than the other. It all depends on the year, depends on several factors, depends on the crop probably. There's several factors that can come into it. Riesling, a lot of places, Riesling is hardier than Pinot Noir and Chardonnay, but in Nova Scotia, it not necessarily is. Again, I think it's to do with the fact that we have a relatively short growing season, so this kind of hampers Riesling a little bit. But yeah. I also thought I'd take this opportunity to give a small plug in here for the Kentville wine grape selections. So back in the 80s and 90s, Andrew Jameson, as part of the small fruit breeding program, he was actually breeding several wine grape cultivars that he thought would be suitable for our region. He came up with several selections. In the end, he picked 3 that he thought were the best. Some of those are already growing out in industry, and a few people have them. Unfortunately, they're not named. Most people like names for their grape cultivars. They're still named after the year. But an update on this is we're still working with these. There's a trial right now that Beatrice Amiot, the current small fruit breeder, is working on, and will be making wines with these grapes with Shauna McKinnon, the chemist in Kentville. And probably sometime the next year or so, they're going to be sent out to a center, a CFI center out in BC, where they're going to be testing them, make sure they're clean, free of viruses. And then in approximately 2 years, they'll be declared clean, hopefully, and then they'll be released to the public and to nurseries to propagate. Once we're sure they're clean, and hopefully we can give them a name in that time too. So 94-2, all these grape cultivars that Andrew bred are white hybrids. 94-2 is a cross between Seville and a previous Kentville selection, 87-1. This other selection, 96-2, is a cross between St. Pepin and Seguride. And finally, 96-4 is a cross between St. Pepin and Lac Blanc. You can kind of see the vine even kind of looks like a Lac Blanc. It has nice anthocyanins on the rachises and on the stems. These are all fairly aromatic whites. So in the last few years, we've also been testing the hardiness of these new selections. As I said before, Lac-a-Dee's hardy. It's a hybrid, but for a hybrid, it's not particularly hardy. It's hardier than the vinifera, but not particularly hardy for a hybrid. And actually, in early days in the 70s and 80s, it was considered fairly sensitive to winter. It often sustained winter damage at the site in Kentville, although our winters have not been quite severe in the last 10, 20 years. And so we don't see that as much these days, but it's still a concern. So finally, this is a plot showing the 3 selections. You can see along the bottom here, 94.2, 96.2, and 96.4, and we compare it as a kind of control to Lac-Di Blanc. They said, I think it was 96.4 is actually a cross with Lac-Di Blanc as well. So this first grouping, this is the bud hardiness levels, LT50 levels. This is the temperature where you'd lose half your buds. That's on the y-axis on the left here. So when we tested them in late fall, November 29, back in 2019, they're all fairly hardy, even going into winter. They're hardy to about -23, and there's no real differences. But interestingly, after we got into the depth of winter, you can see there was some differences. 94.2 and 96.4 in particular were 2 or 3 degrees hardier than the other selection and Lac-Di Blanc itself. So these appear to be hardier than Lac-Di, and they're even down into -30, -31, which is in Marquette territory. So these can be pushed to be quite hardy, these white hybrids. And if these get into circulation, I'd say these are probably one of our hardiest white hybrids that we would be growing around here, which is kind of interesting. I should mention we checked them again this year, and we did not see these differences. But again, if you remember, for some of the hardier, more responsive, more dynamic cultivars like Marquette, they weren't particularly hardy this year either. If you remember, Marquette's usually 2 or 3 degrees hardier than Lac-Di, and this year was only about half a degree hardier. Whereas in the normal year, it's about 3 degrees hardier. So this year with the long season, and we also had a little bit of warm temperature back in February, the differences aren't as great this year. Bud viability. We started this last year. We started doing a survey at a subset of a number of the bud hardiness sites. As part of that survey, we take 10 nodes from 10 canes per site. So that's 100 buds per site. And we did this for a subset of 12 sites over a total 23 sites. And we perform this survey every 4 weeks. If you're looking at the picture here, this is an example of what a dead bud looks like after a freeze. You see the primary is turned black and the secondary is still nice and green. So unfortunately, our year last year was cut short because of COVID, but we did get some interesting data because we did have that February 15th freeze event, which is the first real time since we started the bud hardiness survey that we've ever seen significant damage because of cold temperatures. Normally, we're nowhere close with most of the things that we grow in terms of losing buds as a result of really cold temperatures in the winter, but last year was the exception. So if you look at these numbers, you can see, so what happened to our viability in some of our vinifera? We are tracking 7 sites, and we started at around 96% viable, but after that deep freeze, our viability dropped by about 18%, and they didn't drop at all at some sites, and it dropped significantly in other sites. It all depends on particular sites, but on average, they dropped 18%, down from 95 down to 77. The hybrids, as you would expect, they're far hardier. They only dropped about 6%. Again, the deep freeze event that we had on February 15th that reached down to -25 or -26 at some sites. Other sites were a lot warmer. So the hybrids fared a lot better, as you would expect. Also interestingly is looking at the secondary buds. So that's the difference in the primary buds. What are the secondary buds doing? That's your second option for a bud if something happens in your primary. Usually that's fruitful. So if you look at this vinifera, one thing that was interesting is that the secondary buds weren't that viable to begin with, even in January. They're only down there in the mid 80s. So that could be for various reasons. And even though the primary buds dropped after the deep freeze, almost 20%, the secondaries only dropped about 3%, which makes sense. The secondary buds are usually a lot hardier than the primary buds. They're usually a much smaller bud, usually less fruitful. There's less water there for them to start to freeze. So they weren't affected that much. And the same thing with the hybrid secondary buds. They also weren't affected that much. They only dropped 2%, even though the temperatures were quite cool that night. So frost freeze pruning trials, like I said, there's at least 2 of the last 3 years, our plans changed because instead of doing what we thought we were going to do for a trial, we got either a large frost or a large freeze. So first I'll talk about the trial we conducted in 2018, the June frost. So on June 4th, early morning, the coldest temperature, we had -2 at the research station, and this was the coldest temperature in the Kentville's 100+ year record of tracking temperatures. So it was an exceptional year, and that was an exceptional frost. It did a lot of damage, as most of you remember. This is 3 days after, this is the Kentville vineyard. This is 3 days after that frost, and you can see all the shoots, all the meristems are dead. Greater than 95% of all the apical meristems and all our shoots died. The whole cane didn't die, but the meristem died. The inflorescences, a lot of them died, and but this shoot at the base is still viable. So the biggest question in the wake of a frost like that is, what can we do now? Which no one had solid answers with. So we decided to do a trial. We took 6 cultivars in our Kentville vineyard. We did a post-frost pruning trial, 3 hybrids and 3 vinifera. So there's 3 treatments. This first one was my favorite one. It was not to do anything. So this is a schematic of our vine. We got the frost, you know, the shoots were all blackened at the top or browned and burnt and no longer viable. And so this is the first treatment. The control is the easiest one, just don't do anything. But then we looked at around the world at other people that experienced frost like this more frequently, and there's lots of ideas on what you should do. So one idea was light pruning. People were worried, well, maybe having all this dead material in the vineyard, maybe it's going to, you know, be a reservoir for disease or for molds for molds and funguses to start to grow. So the second treatment was light pruning. So all those blackened tips, the light pruning treatment was actually the most laborious one. We went in there and cut off all the dead parts of the vines and left the base of the stems that were still viable. And the third treatment was heavy pruning. Now, in some of the literatures, especially the extension literatures, I can think of one particularly that came out of Australia. They suggest maybe you should remove all the stems, all the shoots if you have a freeze. The thinking is maybe if you remove them, maybe it'll cause a secondary bud to come up instead. But what we didn't want to happen was to have have just the laterals breaking and have no fruit at all. We thought maybe if we remove the stems, it would force like the secondaries and tertiaries to break. Another thing we didn't want is at some sites, you know, they were kind of half frosted. We thought, well, maybe, you know, if half the shoots are still good, we're going to have like an early crop on those vines from those ones that were made it through the frost. And then the ones that died, they're going to have secondaries come up, and then we're going to have a second kind of crop on the same vine that is going to take longer to mature. So we were worried about that. So anyway, we decided to do a heavy pruning treatment as well. So lessons learned. First thing we learned is that vine mortality spiked either in the year of the frost or in the year following. So some vines went into winter in a weakened state, and then the winter killed them. So we found that mortality in our vineyard actually increased either in the year of the frost because they died that year, or they died the year following. And actually, this was, I think, the beginning of the end for our Pinot Noir. We were experiencing like 2 or 3% mortality before the frost, and they were already kind of a weak vine at our site. And after the frost, you know, mortality went up to 20%. The other thing we learned is that Lac-a-Dix, out of all the cultivars, handles frost very well. Lac-a-Dix has moderately fruitful secondaries, tertiaries, even quaternary buds. They have a propensity to put out several shoots per node, and out of all the cultivars, they gave a moderate yield, even though they had been frosted, just because they're so prone to giving out or shooting up those secondaries and tertiaries, because they were still relatively fruitful. Instead of having 3 or 4 clusters, they probably had 1 or 2, and you still had a crop that was worth harvesting. And Riesling had the best yield for the vinifera. And I trumped this up to being the fact that it wasn't hit as hard as the other ones because Riesling is so late breaking. Only the shoots were so small when they were hit. They hadn't used a lot of the reserves yet, and maybe even a few shoots hadn't even broken yet. And so they had a little bit better yield than the Chardonnay and the Pinot Noir did. So as far as our three pruning treatments, the heavy prune, this hit the vines hard, removing those shoots. The heavy prune treatment, they were the slowest to resume growth after the frost. For a little bit, after like 2 or 3 weeks after it, we actually worried that we killed them because nothing was growing on those ones, and the ones that were light pruned or controlled started growing much earlier, although they did catch up eventually. Yields were typically lowest in the heavy prune, so there went our theory that maybe removing these shoots would induce more secondaries and tertiaries to start growing. That didn't seem to be the case, as we had the lowest yields for the most part in the heavy prune treatment. And the percentage of shootless nodes typically was highest in the heavy prune in the heavy prune treatment in year 1. So shootless nodes or blind nodes, these are nodes where nothing grows. So obviously some of these ones that we removed the half dead shoot, nothing grew there afterwards. In year 2, yields were not affected by pruning treatment. So there was really no difference between any of these pruning treatments and the yields in the following year. Now I'll talk a little bit about the 2020 February freeze event. So on February 15th, 2020, we had a very cold temperature at the KRDC vineyard, along with some of the commercial sites. Temperatures were lower than -25, which is above the LTE 50 value for a lot of our vinifera. We had almost no vinifera that year. And the biggest question again is, well, what do we do now? What do you do with a plant that has 95% plus of its primary buds now dead? So again, another post-freeze pruning trial. So we chose one hybrid, Vidal Blanc, which is a relatively sensitive in terms of a hybrid. Those plants had about 50% bud mortality of their primary buds. And we also did it with Chardonnay, and they had greater than 95% bud mortality. So this time we had 4 post-freeze treatments for this pruning trial. So treatment 1, like generally what you do generally the best thing is to let nature take its course. So this is the most closest to that. Treatment 1 was a 10 bud spur. So we spur pruned this year. This is again our VSP trained vine, a schematic of it. And we cut down all those shoots and left 10 bud spurs for that. Our second treatment was along the same lines, only we left a 3 bud spur, because we thought, like, what do you do with a shoot growing at the end of a 10 bud spur? Sometimes that's 2 feet off the fruiting wire. So can we do the same thing with only a 3 bud spur? And I find most often, the shoots that would break would be these, we call them bud zeros, these ones that are hidden here right next to the cordon. Treatment 3 was a double cane. So we thought we'd include this because maybe people had done this even before, a lot of people had, by February 15th, some people had already finished pruning their vines. And this is a lesson about why you leave your vines unpruned as late as you can. So you have options if you do get a freeze like this. If you've already pruned them, you have very few options of what you can do. So for these ones, we put down a double cane. So in other words, we put down 4 canes, 2 going out each side. And finally, at the temperatures that we had, -25, -26, especially for the vinifera, we were worried that we might have even induced or might have even incurred, vascular damage, not just bud damage, but even worse is having vascular damage, the phloem having frozen. So that plant might have been very weak. It might not want to push very many buds that next year. So we thought we'd, as our last treatment, the most extreme one, we'd cut that cane right back to the head. So we just cut it back to the head, and we were hoping that we'd get latent buds breaking on the head and maybe have more options. We completely ruled out having a crop for that year. We thought maybe we'd have more options for the following year, and maybe the plant would be a little bit more vigorous in its few shoots that it could put out. So I'll talk about lessons learned from the Chardonnay first. This is a heavily damaged, 95% damaged cultivar. So the biggest thing is it didn't really matter what you did. You didn't get much crop that year, although it did go about as you would expect. For the 10 bud spurs, the 10 bud spur, the least aggressive pruning treatment, we had 1/4 kilogram per plant. So, 1/2 pound per plant. This is only about, this is a fraction of a ton an acre. That gave us our heaviest crop, or our biggest crop. The 3 bud spur was about half that. A very small crop. The double cordon was half that again, a very small crop. And when you cut it back to the head, there was very little in terms of fruit in that vine at all. So as we'd expect too, though, the more aggressive the pruning treatment, the more viable options you start getting around the head. So these 10 bud and 3 bud spurs, they only produced about 3 shoots around the head that could be used for cane pruning the following year. Whereas the more aggressive pruning styles, double cordon and pruning back to the head, they gave twice as many shoots. They were, 6 or 7 shoots from the head. So that gave you a lot of options, and that should give you a lot of options in that second year. Now, this column right here, this is the diameter of the largest cane. This isn't the average, this is the largest cane. And usually there is about, usually only about 1 cane that might become bullish on these vines. For the 10 bud spur and the 3 bud spur, nothing was that bullish. Usually something over like 13 millimeters is bullish. So there's no vines, or there's no canes on those vines that were very big. Now, the ones that were in the more aggressive pruning regimen, the biggest vine or the biggest cane on those was becoming a little bit bullish. Some of those had averaged 14 or 15 millimeters. And then we also looked how many weak shoots there were. So I call a weak shoot a shoot that can't even make it up to the top wire. So all of them had about 1 weak shoot. So if you look at these 10 bud spur and 3 bud spur pruning options, if you only have about 3 to begin with, and on average, 1 of those is weak, then you really only have 2 options, and you don't know how good those options are. So you're really limited in what you're going to be able to do the second year on these spur pruned ones. The Vidal was a little bit different because it was not as damaged as the Chardonnay. So we had the same treatments though. You can see even with 50% bud damage, we still had a respectable crop on the Vidal with our spur pruning treatments. It was about 3 kilograms, which is about, with our spacing, 3 tons an acre. On the double cordon, it was less, but it gave 2 tons or 2 kilograms per vine, and back to the head, the crop is much lower, is only a little over 1 kilogram. The story was the same on the number of shoots coming out of the head. Again, this is your options for that winter when you prune for your next year. With the spur prune, you only had about 3 shoots coming out of the head. And for the more aggressive pruning regimens, you had about double that again, about 6. And the story was same as far as how bullish those or vigorous those vines were, a little bit more vigorous for the vines pruned back to the head. And they all averaged about 1 weak shoot as well. So one of those shoots, would not be an option at all for tying down that next year. So finally, I'm going to talk a little bit about frost protection, temperature inversions, and frost fans. Now, there's a lot of, especially these last couple of years, especially in 2018, there's a lot of talk about what you do after a frost. So I thought, again, I know this was covered a little bit a couple of weeks ago, but I'll first talk about the 2 primary type of frosts that we need to think about. The first is an advective frost. So this is a large polar air mass that moves into an area, generally accompanied with wind and cloud. There's not a lot you can do about these kind of frosts. There's a couple things, but when you have cold temperatures and a strong wind, your options are limited. Now, radiation frost is when the heat radiated from the Earth is far greater than the heat being received from the sun. So this is usually accompanied with a clear sky, no clouds, and a temperature inversion. So usually a temperature inversion and with no wind. And and it's usually followed by a very beautiful day. Usually you have these frosts, it's a clear night, it's very still, and there's no wind, and you get this cold temperature, and that next day the clear sky and the no wind is still there, and the sun's out, and you have a beautiful day. So just a little schematic. This is a schematic of a vineyard. So normally the sun is heating up the earth, and typically what you get is all your warm air is next to the earth. The sun radiation hits the earth, it warms up, and then the warm air kind of sticks around close to the earth. You go up in elevation, and it gets a little cooler, and you go quite high up, and it gets cooler yet again. Now, under radiation frost conditions, we get what I'm talking about by a temperature inversion is you have these particular conditions. You have, it happens at night, so there's no sun. You're not receiving any radiation from the sun anymore. You have no clouds, so that radiation is not bouncing off the clouds and hitting the earth again. So you're completely losing that radiation, which cools. You have no wind, so there's no mixing of the air. And because cold air is denser and heavier than warm air, under these conditions, the cold air, it kind of settles out and sits on top of the earth and around your vines. So under these conditions, you now have, instead of your warm air next to your vines, you have the coolest air, and that warm air is found above, 20 or 30 meters above your grapes. And the coldest air is again found well above that. So I won't put too much time into this because most of you probably saw the talk out of France a few weeks ago, but the best thing to do for a frost or a freeze is not to do a post-freeze or frost pruning study. It's to not avoid it in the first place. So there's a few options. There's smudge pots, candles, and fires. They've been used historically. They're not super effective. They're mostly good in a radiation frost. It's hard to heat a whole open vineyard, even with a bunch of fires, very laborious. And usually the thinking was that usually the acrid smoke and creating clouds essentially from the smoke is what provided most of the protection. And so that's kind of frowned upon these days as well. Sprinklers, they're one of the few things that can work in both an advective frost and a radiation frost. Kind of looks beautiful when this happens, but it works on the same principle as the Bud Hardiness Survey does. When you have water and it's liquid and it starts to freeze, it actually gives off heat. So even though it's encrusted with ice, it's also giving off heat at the same time, which keeps those vines kind of protected. You do have to keep on applying the water though to get this effect. You can't stop and have it turn to solid ice. Helicopters, I mean, great if you have one, not a viable option for everyone, although it is sometimes used. The sprays, there's been mixed results using a various number of sprays that you can put on your vines. And finally, frost fans. This is an option used in several places around the world. Again, they only work if it's a radiation frost, so it does not work if there's a wind or it's an advective frost. It essentially works just by mixing that warm air up above with your cold air that's next to your vines. It blows that warm air down onto your vines. So in 2019, the question was, well, do we get radiation frost more often here in Nova Scotia, or do we get the advective frost more often? Different people have their different ideas on what they think type of frost we get. So in 2019, Dale Hebb installed a few towers. Here's the one up in the Kentville research station. So it's a 9-meter tower, and there's temperature sensors all along it, down at the ground at 1 meters, 2 meters, 4 meters, 6 meters, 8 meters, and 9 meters. So these temperatures are being logged at all times. So this can detect whether we're getting temperature inversions or not when we get these frosts. So AMAFRA, the Ontario provincial government, did a bunch of studies for this, 10, 20 years ago. They did a lot of work on this. So they defined a strong temperature inversion as a temperature change greater than 3 degrees over 20 meters. I should point out our tower is only 9 meters, but if you can get a difference in temperature of greater than 3 degrees over 20 meters, then that's a strong temperature inversion, and you can do something about that, maybe with a frost fan or one of these other things. So what I wanted to analyze is we analyzed 1 year of data, 2019, the growing season and the following dormant season. And I defined a frost as or a frost risk as a temperature less than 1.5 degrees from May 5th to November 1st. Now, May 5th is about the earliest we've ever seen bud break here in Nova Scotia. A Marquette or Lucy Coolman in the past 20 years has been known occasionally to break as early as May 5th. And sometimes people are still harvesting up until the end of October, and it's healthy for the vines if you can not if they can hold their leaves at least a week or two after harvest. I mean, after the fruit are removed, the plant is still trying to get sugar that can it can put into its canes, into its fruits, and that helps with the bud hardiness as well. So again, growing season May 5th to November 1st. And in the dormant season, I was interested in looking at temperatures that were greater than -16. -16 is, when buds begin to die on, especially our vinifera. So that's where we begin to see the first signs of some winter damage. So the data, what this inversion tower told us. So here's all based on those definitions, the events, I'll call it, during that defined growing season that we saw in 2019. So on the top here is our spring frost events, and we had 5 of them that year. Like I said, these are temperatures less than 1.5 degrees. And if you're measuring 1.5 degrees at one point in your vineyard, more than likely it's going to be even less than that somewhere, down the hill or in a gully or something like that. So that's why we picked 1.5. Also, if you have a frost fan, it's best to start circulating the air before you actually get to that freezing point. So you want your fans or whatever you're going to do to come on, a couple of degrees above that dangerous temperature. So 5 spring frost events, and we had 7 fall frost events. Now, if you look at these, the most serious one happened on May 11th. Luckily, in 2019, most things hadn't broken by that. And we, let me back up. I also want to point out that you can see this is a clue to what type of frost these are, whether they're radiation frosts or advective frosts. You can see every one of these low temperatures occurred, sometime between 1 a.m. in the morning and 7 or 8 a.m. in the morning. So the fact that it always happens in the morning tells you there's a good chance that most of these are radiation frost, not advective frost. Those usually blow for a day or two and right through the day. But these low temperatures were happening at night or very early morning. So this minus 1.4 happened. It wasn't that dangerous this year, thank goodness. And it was a small temperature inversion associated with this last column is the difference in temperature at 9 meters, subtract 1 meter. So this shows you that the temperature at 9 meters is almost 2 degrees greater than 1 meters. It was a moderate temperature version, not a strong one. Usually a frost fan can bring up the temperature about 60 or 70% of this amount. So a frost fan could bring this up, a little over 1 degree. So at least bring it up to almost 0. We also had a frost event on May 25th, and this one was a little bit more serious. It did get below 0, just though at minus 0.2, but you can see if you had a frost fan, it was associated with a very strong inversion event. The difference between 9 meters and 1 meters was almost 4 degrees. So if you had a frost fan, you'd easily be able to raise this temperature 2 or 3 degrees from that 0. So it'd be more than safe. Looking at the fall temperatures, again, in September of that year of 2019, we did have a relatively strong frost on September 19th. But again, this was like all of these, a radiation frost, and it was associated with a very strong temperature inversion. It was over 4 degrees. These other frosts in the fall, they were getting into October. I guess they were all in October. Each one was associated with a very strong temperature inversion. It was, 3-4 degrees over that 8-meter elevation. So now looking at the winter dormant events. So we had 4 in 2019 where it hit minus 16 or lower. And these are kind of interesting.
Harrison, sorry, 5 more minutes.
Oh, 5 more minutes. Okay, thank you, Francisco. I'm almost done. So you can see on January, most of these events were associated with very strong temperature inversions. Here's that one we talked about earlier on February 15th, where it got down to minus 25. That was associated with a huge temperature inversion, over 5 degrees over that 8-meter elevation. But this one on January 18th, it was more of an advective freeze. There was not really much of a temperature inversion associated with it. Also, I should mention this year hasn't been a particularly cold year, but we did have several times where it hit minus 16 and very few, almost minus 16, minus 15 or minus 16. Very few of those events were associated with temperature inversions. We had a strong wind, as many as you remembered, where you had polar vortex came down and came through the Maritimes there on a couple of occasions. Here's what the temperature inversions look like. So this is the May frost event I talked about earlier. The blue is the temperature, and the red is the temperature inversion that goes along with it. So you can see the temperature drops, and because this is the inversion temperature, this is the difference between that 9 meters and 1 meter, you can see it follows right along with those temperatures. And that's why it dropped out, is because the wind dropped out and that cold air settled out, and that caused that low temperature. Same with that February 15th event. The blue line is our temperatures. It went down to minus 25, and again, it's because the wind dropped out and that cold air settled out, and that temperature difference, reached 5 degrees over only 8 meters. I just want to mention that frost fans, I'm not selling frost fans by any means, and I'm not saying it is the answer for everyone, but and you need to look at the business side of it. But there's approximately 500 of these things running in Ontario, mostly in the wine grape industry, also in some of the tree fruits. And again, they only work with temperature inversions. I want to mention 2 of our last 3 years at the Kentville station. Maybe we don't have the most ideally situated site. It is up on a hill, but it seems to be prone to cold temperatures. So 2 out of our last 3 years, we've been significantly affected by both frost and freeze events. Because of this, we started exploring frost fans for both protecting our vineyard and our research trials. So most fans would be overkill for our site. Most fans can cover, anything from 10 to 12 hectares. The very large fans. Our vineyard's only about 1 hectare. So we ended up buying this little thing. It's called a Hydrolada Tombo. It's a portable, and you can raise it up and down on a boom. Here's a picture of it up in the vineyard. This is the first time we set it up, raised it up. It's about 9 meters tall. That fan oscillates 360 degrees. It runs off a little 24 horsepower diesel engine. Some of the big ones, they take like 150 horsepower diesel engine. Takes about 5 liters an hour. The big ones, they'll take about 20 liters an hour, and they'll run all night, 8 or 10 hours, or they can. This one is purportedly can protect up to 5 hectares. I would say that's under very ideal conditions with a very light frost. Maybe more realistically, it'll protect well 2 to 3 hectares at most, I would say, which is again more than enough for our vineyard. Your neighbors are always worried with frost fans. This is about 45 to 50 decibels. You shouldn't really site these things any closer than about 300 meters to your nearest neighbor. And it can be armed as temperature triggered. So when it senses an inversion event and when it senses that there's no wind, this thing can be triggered if it's been armed the night before. I guess that wraps up my talk. Again, I want to thank Perennia, the Grape Growers Association, the CGCN, and Agriculture and Agri-Food Canada for allowing us to do all this work. And that concludes my talk.
Thank you very much, Harrison. It was a great presentation and really good a chance to see all the experiments done in the Kentville station.
Thank you.
If you have any questions to Harrison, please write in the Q&A feature on the bottom of the page. And in the meantime, we received a question for you. It was when you were presenting the freeze pruning trials.
Yep.
Did you do a yield per bud kind of ratio?
A yield per bud ratio. Like in year 1 or year 2?
I think it was when you were showing the Chardonnay slide, but
I didn't express it that, although I think we have the data that we could express it like that if someone was interested in that data. But yeah, we did count the nodes. I don't think we counted the nodes on the shoots, but we counted the nodes on the cordon, so we could figure out that kind of number. But no, we didn't. I don't have those numbers at my fingertips, unfortunately.
Perfect. And yeah, in the meantime, I also had a question, and that was when you were presenting the bud hardiness part.
Yeah.
You showed the different varieties, but did you see any difference of the same variety but growing in different parts of Nova Scotia in terms of bud hardiness? Or did you have a chance to check it?
Yeah, we actually did see differences in different parts. Now, I can't say that certain regions are always better or always more hardy and less hardy. And it seems to vary from year to year. I can think about one site in particular. It was a Lac-A-D, which is normally, you can see Lac-A-D is normally hardy to -27 or -28 tier. I can think of one site that one year was only hardy to about -23 or -24. And unfortunately, that was the year of the freeze. And it did have significant bud mortality that year. But in previous years, it hadn't been. And then also this year, it wasn't. So there's a lot of variables that go into bud hardiness. The crop load the year before, other things affecting the vine, nutrients and stuff like that. So it can vary per site, based on the site and based on the practices they employed that year, and based on the year as well. Yeah.
Yeah, perfect. Thank you very much.
Yeah.
Okay, we received one more question for you. What would be your overall conclusion on the best pruning treatment after a winter freeze?
Well, I should say, I mean, if you're just looking to get crop in that current year, it's to do nothing or to do the least aggressive pruning. So that 10 bud spur, same as the frost. Quite often the vine knows what, I think your main goal should be the health of that plant. So quite often the least invasive thing to do is probably the best thing to do. The plant can figure out, it'll shut down nodes on its own. If it can't push all the buds, it often do that. But if you're still hoping to get a crop that year and you think the plant can take it, then yeah, doing a less aggressive treatment. Now, we are going to follow up this post-freeze pruning trial one more year. So it'll be interesting to see. I'll just bring that slide up. It'll be interesting to see next year if some of our more aggressive pruning treatments that produce more options. Let me get to this side. Yeah, some of these more aggressive ones that produce more options around the head. It'll be interesting to see if that helps us in year 2, which will be next year. So yeah. So right now, my instinct is to do not as much. Have that spur prune vine and let the plant figure out what it wants to push and not push. But it'll be interesting to see next year if we get a benefit from having twice as many options around the head or not.
Perfect. Yeah, and that was a small continuation of that question, just asking in terms of balance between crop and health of the plant.
Yeah. It's interesting when you try and push a vine, if you try and put down too many nodes, it'll fight back. If you double the number of nodes you put down, it might only break half more of those. So if you try to double your crop by doubling the number of nodes, say you went from 10 to 20, you likely won't double your crop. You might only improve it by 40 or 50%, and the vine will probably suffer a little bit, and your maturity will probably suffer a little bit as a consequence. A lot of these vines, they'll try and regulate themselves, and you can't change that.
Perfect. Thank you very much, Harrison, and thank you very much all the attendees as well.
Thank you very much to join us, and thank you very much, Harrison, for such a nice presentation showing all the information and all the trials done in Kentville. So before finishing and closing this session, please join us again for the next and last session on March 25 at 12 p.m. with Rachel Allison from Cornell University. She will be talking about flavor chemistry and canned wines. Also, I would like to invite you to the Minister of Agriculture digital series. These are 90-minute events to discuss different topics. The next event will be on Wednesday, March 31, and the main topic will be consumer trends in agriculture. Thank you very much to attend to this 5th session, and we'll be waiting you for the next one.